Hello everyone. Today in this video tutorial I am going to take a look over a new sensor that is ADS1100. Now to get a better view regarding this sensor, what we have to do is to log in to the website that is controleverything.com, and here we have to search on for this sensor and let's see what we got here. It's ADS1100 and here you can see it's a 16-bit one channel analog to digital converter, and also you can have some view over some of the features which are clearly visible on this very screen. And the plus point is there you can purchase this sensor from this website from here. Well, for this video tutorial, in the later video I will be interfacing the sensor ADS1100 with the Raspberry Pi and a Python code. And to get that Python code we have to go to this host app, and here comes the Python code as you can see on my screen, and you click over it and you can download this as zip file from here. Also, you can go to github.com and there you can download it from the repository that is Control Everything Community. Well, what do we require next is to have a look over the hardware setup, the connections we need. Let's have it. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter just like that, and you can have on the USB port. The next thing we require is our sensor, that is ADS1100. Now this here is a connecting cable. Now this connecting cable is very useful in making connection with the sensor and the I2C Shield, and making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the I2C Shield, just like that. As we are done with all the connection setup, what do we require next is to have a look over the code. Coming to the interfacing part, the first thing we require is to log into github.com, and here we have to search for the repository that is Control Everything Community. And here this comes the sensor, that is ADS1100, and this here is the Python code we are looking forward to explain. But before that, let's have a look over the instructions we need to follow to pursue this code. And it says that we have to download and install SMBus library on the Raspberry Pi, and this link will help us to install the library and the bus. As you can see, please note down all the relevant information from this very link and do the installation carefully. And after that, this is the command to run the Python code, and note it down also. Now get back to the Python code as you can see on my screen, and it's a .py extension file. In the code, you notice we have imported two libraries, SMBus and time libraries, and we have the address of the sensor, that is 0x48. Now coming to the writing section, we are going to select configuration register and we are going to send the command, that is continuous conversion mode 8SPS1 PGA, and it is 0x0C, and here comes the writing section part. Now coming to the reading part, we are going to read data back from 0x00 for 2 bytes, that is raw, ADC, MSB and LSB, and this is the command for reading part. And here comes the conversion of the data, which is according to the guidelines provided in the data sheet for ADS1100. At the very end of our code, we have the output data to be printed onto the screen, which is the digital output of analog input, and it's exactly the raw value. So this is how the code works. Now let's have a look over the working. Now we have to go to the very interesting part, that is the practicality of the Python code and the sensor ADS1100. And for that, the first step is to copy this entire code of the Python, and then we have to go to the terminal of the Raspberry Pi we have connected using an internet connection, and there we have to create a new file. As you can see on my screen, it's a .py extension file, and after that we have to paste the entire code we have just copied, and then we have to save it. After that, this is the command as you can see on my screen, Python for the sensor ADS1100.py, and here we have the digital output of analog input. As you can see, we have the value is almost constant, but it is also near to the zero, because it means there is no connection of the terminals. There is no end, it's a dead end. But instead, when I try to connect a AA battery of 1.5 volt across to the sensor terminals and I run the command, you can have the values of digital value of analog input, and it's almost constant, near to the constant. As you can see, 6042, it's a raw value. So this is how the sensor responds. Now the next step is to look over the applications along with the features and the benefits of the sensor ADS1100. The ADS1100 is a precision, continuously self-calibrating analog to digital converter with differential inputs and up to 16-bit of resolution. The ADS1100 uses an I2C compatible serial interface and operates from a single power supply ranging from 2.7 volt to 5.5 volt. ADS1100 is designed for applications like portable instrumentation, industrial process control, smart transmitters, factory automation, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.